Okay, welcome to section 7.2. I know this text is really tiny. That's why I need you to look at this on your own computer and print it out. I showed you how to get to it in the introduction video. Section 7.2, we're going to be looking at confidence intervals again. However, this time we're going to be looking at mean confidence intervals. Okay, and practically everything is going to be the same as the previous section. All of the big ideas are the same on how we construct the confidence interval. The only difference is that, instead of having a proportion formula, we're going to be using a mean formula, because instead of finding a proportion, we're finding a mean. And so instead of saying what percent of people are going to vote for me or what percent of people get symptoms from a drug, instead we're going to ask a question like, what is the average weight of something? Or what is the average amount of time it takes for something to happen? Questions like that. Let's just dive right in. Actually, before we do, let's look at what the formula looks like. Again, you start at the question of I am constructing a confidence interval, and you notice that there's a branch coming off that says, are we finding an average? Are we finding a mean? And so if the answer is yes, then there are two separate formulas that we look at. Notice that there's one key distinction here, and that's whether or not we know the standard deviation of the population. If we know the standard deviation of the population, we can use this formula. If we don't know the standard deviation of the population, we use this formula. Notice that the formulas are basically practically the same. The only difference is you either use the population standard deviation or you use your sample standard deviation. And the other difference is that if we know the standard deviation of the population, then we can use a z critical value. And if we don't know, we can use a t critical value. And I'll show you how to do that in the videos that come up. So notice that the formula is slightly different. We still have our critical value, but then instead of multiplying by a weird square root thing, you just multiply by the standard deviation divided by the square root of n. And everything else is the same. Here we go. Refer to the accompanying data display that results from a sample of airport data speed in megabits per second. The results on the screen displayed are based on a 95% confidence level. Okay, so you can see over here, we've got our data from somebody who's already constructed a confidence level, and so we're just asked to interpret it. So we're looking at the speed of your Wi-Fi in an airport, and here's our actual confidence interval right here. It's a 95% confidence level, so that means we're 95% confident that this net captured the true value of the internet speed at the airport. This x bar would be our average, and I'm pretty sure that this would be our standard deviation, and this n equals 50 would be our sample size. The three numbers that really matter are n, the x bar, and our average and our confidence interval. Okay, so let's read these and figure out which one of them is the best interpretation. Okay, the first one says we have 95% confidence that the limits of 13.05 and 22.15 contain the sample mean. That is absolutely not correct, and it is the most common mistake that students make. There is nothing special about these two numbers. These two numbers were just the results from our confidence interval. If we did a different confidence interval with a different sample, we'd get two different numbers. What the 95% measures is the technique we're using, the technique of finding the confidence interval. And so I know that's a little bit of a splitting hair distinction, but it's an important one. Next one, the limits of 13.05 and 22.15 contain 95% of all the data speeds. No, that's wrong. The limits of 13.05 and 22.15 contain the true value. That's definitely wrong. There's always a 5% chance that we completely miss. That's the problem with doing this, is there's always that little probability called alpha that we totally missed our true value. So next one, we have 99% confidence that the limits of 13.05 and 22.15 contain the true value of the mean of the population. That is the right answer. We're 95% sure that we captured the true mean in our confidence interval. That's not to say that it's between these two numbers, but it's to say that it's in this confidence interval. And again, I know that's kind of like splitting hairs, but that's the correct way to interpret it. Let's look at the next one. Here are the statistics for randomly selected weights of newborn girls. We did 246 weights, and the average was 33.3 with a standard deviation of 6.8. Construct a confidence interval estimate of the mean. You know, this is actually going to be a slightly long problem, so I'm going to stop this video here and we'll start it in the next one.